Right now, an interstellar comet called 3I Atlas is still tearing through our solar system on a path that has no end point here and no way back. It is moving too fast to be captured, too fast to be redirected, too fast even for the astronomers at NASA and Harvard tracking it to do anything but watch. This object was never ours. It will never be ours. And what it revealed on its way through is the part almost nobody is talking about. 3I Atlas was first spotted in July of 2025 by a survey telescope in Chile, the same network built to catch killer asteroids before they hit us. Only this wasn't from around here. It's the third confirmed interstellar object ever detected, after Oumuamua in 2017 and Borisov in 2019. It's moving at roughly 60 kilometers per second relative to our Sun. That's fast enough to cross the continental United States in under a minute. Its orbit is hyperbolic, meaning it is not bound to our Sun's gravity at all. It formed around another star. It got ejected violently billions of years ago, and now it's just passing through. Here's where it gets strange. As 3I Atlas closed in toward the inner solar system, it started brightening fast, faster than a simple ball of ice warming up should brighten. Comets brighten because sunlight vaporizes their surface ice, releasing gas and dust. That's normal, expected. But the rate of change scientists recorded didn't match anything in their models for an object this size, this far out. Something was happening to 3I Atlas that shouldn't happen yet, not at that distance, not that early, not that violently. And it kept accelerating in ways their equations couldn't fully account for. Normally, when astronomers see unexpected brightening or a slight nudge in a comet's path, they blame outgassing, jets of vapor pushing the object like tiny thrusters. Case closed, usually. But the math on 3I Atlas doesn't close. The scale of the activity would require an outgassing rate that doesn't match its apparent size or composition. Teams at Harvard and NASA have run the numbers more than once. They keep landing in the same place. The observed behavior is inconsistent with a purely natural, purely icy body doing what icy bodies are supposed to do. Nobody has published a competing explanation that fits cleanly. That silence is the loudest part of this story. So what could explain an interstellar object that brightens too early, accelerates too strangely, and behaves unlike anything cataloged before? One possibility, and it is only a possibility, is composition, that 3I Atlas is made of something rarer than water ice, something that reacts to sunlight in a way we've never directly observed on a comet. Another is structure, that it isn't one solid body at all, but a loosely bound cluster, shedding material unevenly as it warms, throwing off predictions built for smoother, simpler objects. And then there's the possibility nobody at these institutions will say out loud in public, the one that got Oumuamua so much attention back in 2017, that an object which doesn't behave like anything we've cataloged might not be behaving like anything we've cataloged because it isn't what we assume it is. Most scientists reject that outright. But here's the strange part. They still can't tell you, with the data in hand, exactly why it's wrong. The comet is on track to make its closest approach near Mars's orbit around October of 2025, and it will keep moving past our Sun and back out into interstellar space, forever, before anyone gets a second look. Think about what that means. If 3I Atlas came from another star system, formed under different conditions, carrying material we've never sampled, it's a message from outside our solar system, and it's leaving before we can finish reading it. If objects like this are more common than we thought, drifting through the galaxy in numbers we've never accounted for, our entire model of how solar systems form and eject material may be incomplete. And if we can't even explain the behavior of one object we can see clearly with modern telescopes, it raises an uncomfortable question about how many similar objects have already passed through our solar system, unnoticed, before we had the instruments to catch them. 3I Atlas will be gone within months, sliding back into the dark between stars, carrying its answers with it. Nobody at NASA or Harvard can chase it. Nobody can bring it back. So what exactly did it leave behind, and what else might already be out there, heading our way, that we simply haven't seen yet? Tell us what you think it is in the comments.